Now we have a tech demo entitled Adaptive Networking, presented by Chris Taylor, CEO of Aalyria.
I would cheer for me too. Talk amongst yourselves while I'm... Okay, am I good to go? Well, good afternoon. I hope I'm not the person that's keeping you from the bar. I think you have other things. My name is Chris Taylor, founder and CEO of Aalyria, and I first want to say and offer my deep felt thanks to my dear friends, Aalyria and Aalyria, who are wonderful humans, fantastic for American national security, and seem to always find a way to slip me into their programs when they can, much to their regret, I'm sure. I'll tell you a little bit about us, and I'm going to give you a demonstration of our platform called Space. How do rock stars do this? Like, how do you see everybody at the same time? Anyway, about 4 years ago, I and some investors acquired two technologies from Google. One we call SpaceTime. You may know it as the operational platform that ran Google Loon, the balloon program. The other thing that we acquired was a program called Sonora. It was undeclared at Google, but it was a high-speed free space optics program that was meant specifically to go direct ground to space, space to ground at no less than 100 gigs per second through the atmosphere. We pushed those things together, we created Aalyria, and our focus is on networks in motion at planet scale. I just told you about those two fine pieces. I'll give you 2 seconds to read that. So the conversations prior to this have been fascinating. If you imagine just for a second that we have put up into space over $1 trillion worth of things, and to include all the things on the ground that support it, how many of those programs do you think were meant to speak to another program? Yell out a number. 0 should have been the number that you yelled out. We just don't do it. All of our things are so mission focused that we didn't really anticipate one program speaking to another. SpaceTime is what was developed at Google and that we acquired to help us do so. Here's our Tightbeam platform as well. So we're pushing light at 100 gigs from an aircraft 200 kilometers away. I'm not sure, for those of you who are familiar with free space optics, I don't think anybody else is doing that on the planet right now. We have a range out here that does something about 50 kilometers from an urban area to a mountain area, I'll just say that. And we're pushing 100 gigs 24/7. Very important when you talk about LPI, LPD, LPGA sort of operations. For those of you who are familiar with software-defined networking, this should not look unfamiliar. Northbound interfaces, southbound interfaces. This is traditional software-defined networking. What we've done is we've also developed east and west APIs so that we can actually talk to everything else that has been developed, right? So if it's two compatible capabilities, we can bring them into a system to form one network seamless and resilient across the planet. We'll talk about that in a little bit. This is another view of it that just shows some of the people that we're integrated with already. There are many more than this, but this is just representative. And then, you know, sort of from a government perspective. So the Aalyria SpaceTime platform is the foundation for DOW's hybrid space architecture. That is connecting commercial to government to allied to civil, et cetera. So one of the things that we work on is how do we do all that? Because the ultimate goal is for us to get to something like this. How can I make all of the commercial clouds, Five Eye, AUKUS, NATO, commercial SATCOM, all the civil, how can I make it so that they speak to each other all the time in a resilient network that can never be brought down? You can do it technologically today. I hope you can imagine when you see this picture here that this is much more about governance and permissions from all of these different owners of assets to be able to allow other owners who would like to use those, or users who would like to use those assets to use them. A political problem, really, not a technological problem. One of the things we did to make this easier is we put all of our APIs up on GitHub. So right now, any company can go to github.com/Aalyria and build connectivity to our APIs right now. But we went further. We created something called the Outernet Council, and we donated the APIs so that anyone in the world who would like to help develop them could. We don't have the final say. As a matter of fact, we have a separate board that actually does the technological assessment of what should be included in the API or not. Why did we do this? Everybody and their grandmother back in the day set up some sort of API that was very bespoke to them. And then when you try to use it with somebody else, they would tell you, you can do this, but it's going to cost you $1 billion for me to integrate with that thing. We're trying to take all the integration out. It's an open API. Build to it, it will work with everything else that you want to. This frustrates traditional companies who used to make a lot of money on this, but you know, it's 2025, so they got to deal with it. Okay, that's it for that part of it. Let me go to the network. All right, so what I'm going to show you is about 10 minutes, 12 minutes and 12 seconds worth of SpaceTime. So what you're looking at here is our UI just to demonstrate the capabilities of SpaceTime. If you look out here, you'll see we have satellites in GEO. If you look, oops, sorry, a little Wi-Fi. If you look out here, you see satellites in GEO, satellites in MEO. And then here, you'll see a bunch of LEO satellites that kind of, sort of, but not really mimic the proliferated warfighter space architecture from SDA. Okay. Just to orient you here, we have, wherever you see green right now, I have it on status. Wherever you see green, it's saying these links are working. Whatever you're trying to send over these links, they work. But if you look a little bit closer, and let's pick, I don't know, Indo-PACOM. If you look here, not only do we have satellites, but we have planes here. We have ships here. And here I have jammers. So the ships and the planes are live data from ADS-B and AIS data, just so you know that we don't can the demo. We need moving things to show you that the network can work properly, so we just import this data. We have also imported live data from, weather data from NOAA. You can use any data set or weather data set that you'd like, but we import NOAA because it's easy to show you. Right here, we are showing aircraft, gateways, GEO, LEO, our own facility in California, MEO, points of presence, ships, and different user terminals. Right now I have this on status, but if I go to frequency mode, you can now see that we have operating KU band, KA band, optical K band and V band, all the way across the planet right now. You'll notice that it's changing on its own. That's because our AI-driven platform is constantly looking for what we call the satisficing solution in order to maintain the connectivity that you, the user, have ordered, right? So it's not necessarily the most optimal solution. It is the one that meets all of your criteria for being able to connect to something else and to deliver packets somewhere. Okay, and what else do we have here? I showed you weather delays. What we have right now is precipitation, but we can also show cloud moisture. Not clouds, but cloud moisture. Remember, things like temperature, cloud moisture, winds, they all serve to have some sort of an effect on some type of communications, right? Particularly optical in this case. But different bands react differently to different types of weather anomaly. We've brought them all in. I'll go back to precipitation. Perfect. Map view. On some of our other things, actually we put a bunch of comm sites on all the Apollo landing stations on the moon and then created a Lagrange point. It's not in this particular demo, but it's kind of cool, is all I'm saying. Okay, so the coolest thing that you'll see here, because this is what really matters, I've got 8 minutes. So if I go to this area of the world, which is the Indo-PACOM region, I can see that I've got optical connectivity, I've got KU band, KA band, etc. But what happens if one of our assets dies? Either I have to drain it for some reason to do something, or it becomes the victim of an adversary attack. How many of you are familiar with the term PACE? Yes? Okay, it stands for primary, alternate, contingency, and emergency. It is the process that military planners go through for connectivity to make sure that they can continue to fulfill a mission. A lot of time goes into PACE, and the reason I'm making a big deal of this is because I'm going to show you PACE in 200 milliseconds. Okay. Let's have a look at, well, let's go to this satellite right here, LEO 102. On the right-hand side here, you can see, for all of you network nerds, this is sort of the networking view of what the system can do. And we'll see that this particular LEO satellite has 18 links going through it, and it's got 62 transitioning services going through it right now. So there's a lot of stuff going on with this satellite. So this is what I'm going to do. I'm going to kill it. I can edit the interfaces. I can take out all kinds of different things, but I'm just going to disable all of it. And so I want you to focus. This is where this satellite is right now that we just tried to kill. And there you go. You just saw every single one of the services that I just showed you were recalculated and moved on to other assets to continue the missions that the system was already holding. Those of you that are familiar with PACE, do you have anybody have it? Well, let me ask this. Anybody who has anything to do with satellites, how long do you think it takes planners to replan missions after a satellite has been killed? Go ahead, scream out a number. Huh? Say it one more time. Days, 2 weeks. Yes, anybody else? 2 months, we got to get a little bit better. Yes, it's sometimes 72 hours, it's sometimes a week, and depending upon what the satellite was doing and what the rest of our assets are doing, it could be longer than 2 weeks. What you just saw was PACE planning driven by AI, executed, technically it was executed in 200 milliseconds in our software, but the UI, if I put it on 200 milliseconds, things will just start jumping around. My point is, it was recalculated in 200 seconds to the best satisficing solution. Why is, oh, sorry, let's kill another one. I'm feeling 130. Same thing. Okay, so we're paying attention to this satellite right here. And in the time, it's gone. All of those missions were moved off to other assets that we own in order to continue a mission. I can do this over and over and over until I have no more assets. As I do that, surely some of the missions will fall off, but because we're able to prioritize these missions, ones will fall off, twos, then threes, then fours, and five, but tens will always get what they're supposed to get to be able to continue the mission. We have not been able to do this before in the US military. We just have not. And after the last 3 years of sort of going on an education campaign and showing people how it works and what it can do, this March, we will actually be doing the first live demo of DOW's hybrid space architecture. So we will be live controlling commercial assets, US government assets, allied assets, civil assets, and then we're going to be able to connect them to various commercial and government user terminals on the ground and connect it to hyperscalers. So we'll be able to connect it to a bunch of POPs, points of presence as well. Why is that important? Because heretofore we haven't been able to sort of create the resilient network that we've all look, for the last 20 years, you can go to any DOW PowerPoint and see a lightning bolt where connectivity is supposed to be. We've removed the lightning bolts and created the connectivity. That's what we've done. And we've done it in an open API manner so that nobody has to pay for any sort of wild integration. You just have to spend the time to build to the API, which I got to tell you is not that long at all. 2 minutes and 51 seconds. Anybody have any questions about anything I just showed? Does anybody have any questions about anything that I've said? Come on now, feel free. Even if you're going to throw me a bone, don't be afraid. Y'all just want to go. Again, my name is Chris Taylor, founder and CEO of Aalyria. This is coming to a knock near you soon. But what it really does is, instead of creating one strategic dilemma against our adversaries, this spits out 10,000 strategic dilemmas per second. You cannot manage to get through this. Now, you could ask, okay, what if we blow up all of LEO? Well, I've still got MEO and GEO. What if we blow up all of MEO? I still got GEO. What if I blow up all of GEO? We're in a bad, bad way if we've killed everything in space at one time. But we don't only control satellites, we control everything else. You saw we had aircraft, ships. We can make a network out of anything that is in the system. So with that, I will give you back your 1 minute and 37 seconds. Thank you so much. Aalyria, Ely, thanks so much.
For our next session titled Space Sustainability, please welcome Charity